Hi scholars, today we're going to start looking at linear equations and inequalities on the SAT. So before we begin, just a quick review. We have a sort of solution pathway. This is something we can use if we're stuck at a problem. It's always a good way to sort of get unstuck, right? So first step is to annotate. Then you want to summarize. What is this question even asking? You want to sort of think about a plan, what solution pathway you're going to take. Follow that pathway, right? This is where the heart of the matter is, actually solve the problem, right? Always be asking yourself, does it make sense? And then, of course, you always want to get in the habit of checking your work. And again, asking, does your solution make sense? Is it just gobbledygook or does it actually make sense? Right? So we want to always keep in mind, annotate, summarize, plan, solve, and check. And there are also, of course, some nice problems or questions that you can ask yourself if you find yourself being stuck. And not all these questions are going to help you, of course. Some of these questions are not they're not all applicable to all problems, but if you get sort of used to coming back to them and using these strategies, these are different kinds of strategies, it really will help you as you move forward. You get more comfortable with using them. All right. So that's enough of that. Let's take a look at a few SAT problems. Okay. When 4 times the number x is added to 12, the result is 8. So I could underline it all, or I could just write when 4 times the number x is added to 12, the result is 8, right? This is sort of like in middle school, the big idea of algebraic representation. You can just change sentences that look like that into actual equations. So the question is, what number results? So what number results when 2 times x is added to 7? So that's the question. If this is true, then what is this, right? What is this 2x plus 7? So, okay, we can easily sort of treat this as a two-step equation. You can subtract 12 from both sides. You end up with 4x is equal to -4, in which case, right, we could get x is equal to -1 and -1. We just plug it right in here. 2 times -1 plus 7, and that's going to give us -2 plus 7, which is 5, and that's our answer, right? So that's a nice sort of nice warm-up problem. Just a quick note, in this problem, it made total sense to solve for x and then just plug it in. Sometimes it may not be necessary, or it might be slightly easier to not solve for x. So in this case, for example, just want to show you another possibility, right? So in this case, we had that 4x was equal to -4 in this spot, right? Now I could have, since I want to find out what is 2x equal to, since that's my goal, I could have divided both sides by 2 here, right? I could have ended up get the 2x was equal to -4 divided by 2 is -2. And now when I know what 2x is, what that quantity is, I could have just plugged it right in there, right? And gotten it was -2 plus 7, which of course is going to get me the same answer. And of course, in this case, it didn't really save me any steps. But sometimes it will save you steps. We'll see that a little later in the semester. And so you always want to be thinking, do I need to always solve for x? Sometimes you don't always need to. Okay, let's take a look at another example. So before I even begin reading, I see that B, it looks like B equals something else with x and C equals something with x. All right, so let's see what this is all about. In the equations above, B and C, great, there they are, represent the price per pound in dollars of beef and chicken, that's why they use a B and a C, beef and chicken, respectively, X weeks after July 1st during last summer. What a messy sentence that is. It's a lot of commas, a lot of information there, and so it might be useful, right, if we want to just go back and let's summarize that, right? Summarizing, step 2, summarize. And let's summarize this question. And basically, or this situation, basically, I got 2 equations, and they're telling me how much beef costs and how much chicken costs, depending on this x weeks, depending on what time it is, right? There's an x, right? So I don't really care after July 1st, Okay. So the question is, so we can box it, what was the price per pound of beef? Okay, what was the price per pound of beef? That's our goal. Our goal is to answer this question, okay? When it was equal to Oh, equal to the price per pound of chicken. Okay, so that's good information when it was equal to the price per pound of chicken. So I can go back and I can say, really, this question is asking us when B was equal to C, right? That's when these two things were equal, yeah? Then what was B? Okay, so I can rewrite this whole question as saying, when B equals C, what is, right, the value of B? That's what this question is asking, right? I don't even need this whole paragraph right here. If I have this information and this, I can solve it. So when B equals C, so let's set B equal to C, right? So I can set 2.35, right? You see where this is going? Plus 0.25x. There's a little dots there. And I can say it equals to 1.75 plus 0.4x. Okay, so very quickly I can move this one over, move this one over. I can, right, sort of solving the question, or solving the equation. So this would be 0.15x, and this should be, let's see, it should be about 0.60, right? I believe that's the case. And you end up getting that x is equal to 4. And so x equal to 4 is not one of my answers, of course, right? Because I'm not being asked what is the value of x. It doesn't say how many weeks after July 1st are they equal. It says what is the price per pound of beef. So what is the value of B? So once I solved for x equals 4, I got to plug that back in to my B, right? Now, of course, when B equals C, I could easily plug it into C, but let's just plug it in right here. So the price is going to be 2.35, right? Plus 0.25 times 4, which is otherwise known as 1, right? 25 cents for 25 cents is $1. So that ends up being 3.35. And that is your answer. Your answer is 3.35. Great. Let's take a look at a couple more. So here I have, it looks like a system of linear equations, and it's just asking me to solve a system of linear equations. So that's nice. I don't need to underline things really, right? If we're going back to our 5 steps here, I don't need to annotate. I don't need to summarize. I could plan a little bit in my head, but really I can just jump straight into solving, right? Because a system of linear equations, as this is, it's a very common type of a problem. So there's many different ways we can approach it. We could do substitution method, we could do the elimination method, we could even graph them, right? When I look at this, my first step is when I say about what's going to be the easiest solution strategy, which basically means the solution strategy that has the fewest number of steps, right? If I want to reduce the number of steps, then that'll minimize the potential for making an algebraic error of some kind. So if I look at this, I want to say, what's the easiest way to do it? There's a couple different ways I could do, right? So one is I can see that I have a 4y and a 2y, right? So if I wanted to use the elimination method, right? Let's use the elimination method. Because 2 is a multiple of 4, right? It's easy to go from one to the other. I could, right, multiply this entire equation by 2, okay? And I'm going to rewrite it so that the x comes before the y, and I would end up getting that I would have a negative 2x, right, plus 4y equals to negative 38. Just by multiplying that bottom equation by 4, I'm just going to recopy the equation on the top. I didn't even touch it, right? So we see this is all happening right here, right? And then the nice thing is, if I just subtract, right, one from the other, I immediately get 3 minus negative 2. That's going to be our 5x. 4 minus 4, that's the whole purpose of the elimination method. These cancel each other out. And negative 23 minus negative 38. Do your calculator, or it's just 38 minus 23. It's the same answer. You're going to get 15, and you end up immediately with x is equal to 3. And now I could plug it in and solve. But before you do, right, let's look at our answer choices. There's only one of them that has x equal to 3. So you can be like 99% sure that that's your answer. However, again, let's check our work, right? So we did our work, especially with straight algebra problems. You always want to make sure, did I mess up? Did I drop a negative somewhere? So let's check our work. So if I have that x equals to 3, let's see, is it actually true that y is equal to -8? So you can do that by choosing one of these equations and just plugging it in. Let's choose the top one, why not? So we have 3 times 3, I'm plugging it in, plus 4y equals -23, okay? So that's 9 plus 4y equals to -23. We're going to subtract 9, so that's going to equal to -32. 4y divided by 4, y equals -8. So that's good. That's a lot. It looks like when x equals 3, y equals -8, certainly for this first equation. If we wanted to check even further, we could plug these two numbers into the second equation, right? Just to be 100% sure. But yeah, I would say that's a pretty close, accurate way of doing things. So we have our answer. Great. Let's take a look at one more question. So in this question, before I read, just from looking at it, looks like I have two inequalities that have x's and y's, a's and b's, talking about solution sets, and all the answers are about a's and b's. So this is what I would call a very abstract problem, right? These numbers, or these variables, don't represent anything except for the math, right? It's just, they just have meaning in terms of like what the math is, okay? So let's try to take a stab at this problem and about how we could approach problems that look very abstract, okay? So first off, just as an overall thing, when you have equations or inequalities, right? They're representing relationships between two variables, and for the most part, there's going to be x and y, right? And so they're telling you constraints about the variables x and y. For example, like if you knew what the value of a was, right, you would know possible values of x that would relate to possible values of y, right? That would make this inequality true, right? That would make this, whatever's on this side of the inequality, always be larger than whatever's on that side of the inequality, for example. Okay. So let's read the question and see what we can make sense about it. In the xy plane, sure, if 0, 0 is a solution, I'm going to underline that. It's really important. If 0, 0 is a solution to the system of inequalities above, that's all it is. A system just means more than one, right? And there's two inequalities. Which of the following relationships between A and B must be true? So this is, the question is asking us about relationships between A and B, and it's really important that these relationships must be true, right? It could be that they are true, but must be true means there's no way they could be false, right? There's no possibility. Okay, so initially, just from reading all that, I have no idea what the answer is. I really do not, right? But we can start to use information that we're given. I identify that this is important. 0, 0 is a solution. Well, what does a solution mean? A solution means when you put that pair into an equation or an inequality, right, is true. So let's put in x equals 0 and y equals 0. Let's plug those into these two inequalities and see what happens, okay, right? So our first inequality, which is y is less than -x plus a, well, if y is 0 and x is 0, let's just plug those in. It would look like 0 is less than -0, which is just 0, right, plus a, right? Otherwise known as, this is nothing more than saying that 0 is less than a, right? Which we could even, right, these are the same thing, okay? We could even go even further and say, well, what does it mean if 0 is less than a number? It means, just in parentheses, it means that a is a positive number, right? Okay, let's keep going. Plug in 0, 0, again, to this inequality. Now I have that 0 is greater than 0 plus b, which, right, we can rewrite that as just saying that 0 is greater than b. Okay, well, what does it mean if 0 is greater than a number? Well, it means that that number is negative, right? So just from plugging in these values into these two inequalities, I know that A is a positive number, B is a negative number. Let's go back. It looks like all these questions are asking what's the relationship between A and B? Yeah, sure. What's the relationship between A and B? Well, if A is positive and B is negative, I know for sure it must be true that A is greater than B, because a positive number is always greater than a negative number. This is always, it must be true, right? And so A is greater than B, and I'll be darned, right? There's no other possibility, because positive numbers got to be greater than a negative number. Have a great week.